any medium that's constituted of multiparticle system, when comes under disturbance, wave is generated usually, and this wave propagates in space and time towards the full extent of the medium. Now, when there is some obstacles or symmetry breaking in this particular medium, these waves that propagate or these disturbances those propagate in this particular medium becomes a directed vibration, and this directed vibration usually goes by the name state of polarization, and it is directed in the direction in which the disturbance is actually taking place. In our universe, the two mostly found disturbances are, one is gravitational and another one is electromagnetic. In vacuum, that's there is nothing, both of these disturbances propagate with only 2 degrees of freedom. Told compactly, the electromagnetic degrees of freedom or gravitational waves degrees of freedom in vacuum are just 2. On the other hand, if it is not vacuum, it's made up of some material medium like charged particle or matter or anything, this 2 degrees of vibration doesn't remain 2. So, one needs to actually account for the states of vibration of these degrees of freedom in a medium, and that brings into account the state of polarization in the medium, because these disturbances, when they start propagating, they actually polarize the medium because it's a collective excitation. And not just that, each degree of vibration has its own state of polarization. So, depending on the number of possible degrees of freedom, which usually is 3, the number of polarization states those appear are also 3. In a medium, when you are describing their state of propagation, then apart from their density, the amplitude of vibration, the energy, the coupling constant that couples the medium with the excitation, there exists one more thing, and that's also a vector quantity, that's called the medium velocity. Now, contrary to general assumption, this medium velocity is actually a quantity that depends on certain symmetries. So, this symmetry is basically related to charge conjugation, parity violation, and time reversal symmetry. And due to this symmetry, the propagating modes that propagate in the medium have different properties. In general, in our universe, we have various kinds of mediums that vary from stellar interior to laboratory, and in each medium, these disturbances propagate with its unique characteristics. This particular set of lectures, I have planned to bring out these characteristics as it is understood from the angles of what you call the finite density statistical mechanics. And using this, I will try to present before you the variables those can describe this state of polarizations and how we can make use of them to find out more about the medium that constitute the propagation of these disturbances. Thank you.